Okay, now that we've gone through an example of a Lagrangian cost min function, I want to do a quick graphical example to sort of give us the intuition of what's happening. So if we're trying to minimize cost to produce a certain level Q, suppose this is the Q we have to hit, then what we can think of is what we're doing is we're finding the isoquant. We've got the isoquant that is all the combinations of K and L that give us produce Q with a bar over it. And then we have isocost curves, right? And these things have, these are all the lines that have where the combination of capital and labor cost the same. And we're trying to find the one that is the cost curve, the isocost curve, that's closest to the origin, but still intersects somewhere with this isoquant, because we need to have at least this many. And remember, the slope of these isocost curves is negative W over R, okay? And the slope of this isoquant is the marginal rate of technical substitution. And so right at this point here, where the isocost curve just barely touches the isoquant, we're going to have the slope of the isocost curve be the same as the slope of the isoquant. And so we're going to have this condition here. And then we're also going to have the condition that whatever combination of capital and labor you choose, if you plug them into the production function, you're going to get back out Q bar. So this is two equations and two unknowns, okay? Capital and labor. Okay, and then once you have capital and labor, you plug them in to the cost function WK. It's not WK. Where are we? L plus RK to get the cost of associated with that isocost curve, okay? And that's actually what the Lagrangian is doing, okay? It's generating all this stuff, but without kind of the graphical intermediate step. So if we write out an isoquant or a Lagrangian here, like so, if we take all of our first order conditions, we end up with W minus mu, and the derivative of this production function with respect to L is the marginal product of labor. Okay, that's another way to write it. Our next condition, that's equal to 0. Our next condition is with respect to K, we get R minus mu times the marginal product of capital. Because if we take the derivative of this thing with respect to K, we get the marginal product of capital. That's going to be equal to 0. And then we have, with respect to the Lagrange multiplier, Q bar minus FKL equals 0. Now, this last one here, if we rearrange it, we get this equation right there, okay? And these two here, they take a little bit more rearranging, but they give us this condition here. So they give us the two equations and two unknowns. Let me briefly show you how to combine these to get this equation, okay? So we can first rewrite the top one like so. And we can rewrite the bottom one like so. Remember, this little fancy cursive m is called mu, the Greek letter. And we divide the one by the other, and we end up with W over R equals MPL over MPK, because these mu's cancel out. We can stick a negative sign in front of both of them, and this is the marginal rate of technical substitution equal to the slope of the isocost curve. Okay, so that's where that stuff is coming from. Okay, the other thing is, these cost functions, it's worth spending a minute to think, like, what does this mu really signify? Well, if we rearrange this condition up here, we can write it like this. Mu is equal to W divided by the marginal product of labor. Or we can rearrange this one, add mu times mpk to both sides and then divide by mpk, and we get this alternative definition. Okay? What's that telling us? Well, it's saying that if you wanted to make a little bit more, if your goal, if your output Q bar was raised a little bit, it's telling you how much extra it would cost to achieve that, okay? Because if you needed to produce a little bit more quantity, you need to hire more labor, or you need to hire more capital, or actually you'd probably hire more of both. But suppose you're just going to hire a little bit more labor, okay? The amount of extra labor you need, we can find that by dividing by the marginal product of labor, because 1 unit of labor times the marginal product of labor is equal to some Q, and if we want just 1 unit of Q, we can divide everything by Q, and we can get the same kind of thing. All right. And so the amount of extra labor we want, we multiply that by the wage rate, and that's our cost. That's the increased cost to produce that extra little quantity. Similarly, if we need a little bit more capital, the amount of extra capital we need, we divide by MPK to figure out the K that we need, and there we go. That's how much, we multiply that by R, and that's the cost of this extra capital. So that's kind of the intuition for what we're trying to do when we do this Lagrangian method. It's sort of reenacting the graphical version of the argument, and we have this new extra variable, which sort of seems like it comes out of left field, but if we dig under the surface, its interpretation is kind of sensible. It tells us some information about how binding that constraint is and how much more expensive things would be if we had to increase our output.